Hi there, Jason Nell with Beach Drone Services here. I appreciate you giving me a minute of your time. Normally I map construction sites with drones, and after Idalia came through and eroded our beach, I decided to see what I could do with those same drones on a place very near and dear to my heart, Indian Rocks Beach. So I live just across the bridge here. This is Walsingham Road, turns into 5th Avenue North. And what I did is I just basically mapped a one block area from a little past the erosion control line, which is shown here in red, out to the beach. Want to make one thing completely clear right off the bat. We are very accurate east and west to our base map. Actually, my map is completely accurate. The base map is not so accurate. It's actually off about 8 feet to the north. If I turn off my map and you look there, it's off 8 feet to the north, maybe a foot to the west, or to the east, I'm sorry. But east-west, we're very accurate with this map. North-south, not so much, but we're not concerned about north-south measurements in this map anyways. So let me get my map back on. That's the one we care about. And I want to look at some measurements that I made here. Basically, I stretched a line from the old high water mark to the new high water mark. It looks like this might be a high water mark, but I was out there, and that was created while we still were in a king tide. And this is the normal high water mark here. So if you click on that line, you can see a couple of interesting things. There's also a lagoon here that didn't used to exist before. So this is the old data. This is my new data. This was, I think it was taken in June of 2022, so it's not that old, but it is dated a bit. But that is 40 feet, so our high tide now comes 40 feet closer to our homes in Indian Rocks Beach than it did before. I also measured the erosion of the vegetation, so if you click on that line, it'll show you that there's about 31 feet of erosion, and that is what our dune looks like now, when it used to be a large dune out there. So we lost 31 feet of dune. These profiles are interesting in regard to showing you that elevation data when we get over to a three-dimensional model. So what I'm going to do is I'm going to create a line here. It goes all the way back here, almost to the erosion control line, all the way across the top of the dune, out over the lagoon, and down to where the water starts right now, which I think is around there. So I'm going to close that out. It'd be interesting to see this profile, so you can see coming off the bushes there at the erosion control line, and then we slant up for the old dune. The old dune crested right there about 8 feet above sea level. Then, of course, we immediately lose about 4 of that feet within 1 foot of horizontal travel straight down the edge of that dune, and then we go down. This right here is the divot where the lagoon is. You can actually see the blue cursor moving along the line on the map. As I do this, it shows you where that starts and stops. Really gets interesting when you go into 3D mode. So I'm going to hop over to the 3D model here. Take it just a second to process. And this is truly a three-dimensional model of Indian Rocks Beach, or at least a portion of it. It's interesting and very detailed, like you can't imagine, down to, I believe, 0.36 inches per pixel. So each individual square pixel in here covers about 3 inches of actual terrain. So one of my favorite things in this whole map is this sea oat. Right, I believe it's a sea oat. I'm not a plant biologist, but this thing held together this little section of beach. Most of its roots got ripped out. I don't know if it's going to make it or not. Someone should do something about it, but look how much beach that one little bush saved. I mean, if you look back here, you know, this would have been cut back like this. It's just probably hundreds and hundreds of cubic yards of sand that one little thing saved. So if anybody's wondering whether vegetation is important, there's your answer. And also, they had this beach access closed off after Idalia, and of course the good citizens made their own path out here, but you can literally see the destruction that they did to the area there, and you can also see what they did to the end of the dune here. Kind of having a little bit of a tough time there, but you know, not a lot there because it was already there wasn't much there in the first place. But some of these areas, if they had been walking off this, it would have created a big problem. So that's just some of the things you can do. Of course, you can also see the erosion control line in this model. It's not as accurate in the 3D model. More than likely, this line exists right along this hard wall here, but the file that I had showed it going along what they call beach trail, which isn't very well mapped and marked in this map. So, long story short, I want to show you the types of data we can see and visualize from this. First thing we can do is turn on contours. My elevations are not right in this for whatever reason, but sea level is set correctly, and you can definitely count in fives. The dark lines are 5 feet, the small lines are 1 feet, so it gives you a good idea of the accuracy of the model. We can also turn on digital elevation data, which is just a way to color code elevation. Nothing too fancy there, but they use this type of digital terrain model and digital elevation models in civil engineering and coastal ecosystem management quite frequently. So that's just a few ways you can look at the data. You can also look at it as a point cloud. This map is made up of many millions of tiny little dots, and that's what these are here. Each one of those dots is truly a point in 3D space that is really, really, really accurate. And so basically it takes those and combines them with photographs that it took while we were doing this and overlays it to give you that. Or that is what I really meant. So that should give you a pretty good idea. The only other thing I want to talk about is the export functions. We can export into any PDF maps, geotiffs, point clouds, elevation models, digital terrain models, 3D models, anything under the sun, whatever software you guys use, SolidWorks, so you can take shape files and DXF files, everything under the sun. So I'm here. My company is ready to help. We believe in our coastal ecosystem, and any way we can be of service, I would love to talk to you at length about that. But this will give you a good idea of what I'm doing and what the capabilities are. We got another drone on the way at the end, or at the beginning of November, that's literally going to be centimeter level accuracy, and it has a ground stake that tells you exactly where you're at using RTK. So it's a very sophisticated system, and it's about a month out. So hopefully we can use it together to help ourselves with our little coastal ecosystem problem. Thanks for your time. I'm Jason with Beach Drone Services. You've got my contact information in this email, and I look forward to hearing from you. Thanks.